Thank you for joining us for the Safety Center's June webinar, usRAP and Innovation in Data-Driven Safety Analysis. We're going to be getting started right now. I'm going to close all these polls. It looks like we have a good representation from across the U.S. today, with about 30% from the western U.S., 38% from Midwest, and about 15% from each the Northeast and the Southeast. We have most people joining us by themselves, but we do have a few people in groups of 2 to 3. For those that are joining us in groups, if you could please send us a list of those people who are joining you and their emails to our email at it's info@ruralsafetycenter.org. That will allow us to send our evaluation to you after this. The evaluation is the only way that you will be able to receive a certificate of completion or CEUs, which are both given for free, but we do need you to fill out the evaluation form in order to receive those. So for anyone that's in your group, again, if you can send us an email letting us know who else attended and their emails. It does look like most people are joining us from their computer only. And it also looks like we have a pretty good representation again today from the different organizations. So we have several people from the federal DOT, several from state DOTs, and several from local DOTs, about 10, 15, and 18% from each of those. We do have a few tribal government representatives, about 14% from universities, 14% are private consultants, and then we have about 24% making up other government agencies. So a few webinar logistics for you all for today. The duration of this webinar is about an hour and a half from 11 o'clock Mountain Time to 12:30. This webinar is being recorded and will be archived on our website within a few days. Under our training page on our website, we have both a registration page where you can find our webinars that are upcoming, as well as the archived page, which posts all of our recorded webinars so that you can view them again at your leisure. If you are listening on the phone, your phone has been muted for you, but you should also mute your computer. Otherwise, you will have feedback if you can hear us through both your phone and your computer. If you're interested in maximizing the presentation, you can click the 4 arrows that are in the top right-hand corner of the presentation, and that will put this in full screen mode for you so that you can see things a little bit clearer. We are going to be having a live demonstration as long as it works as we're live today. And during that period, we would encourage you to use full screen mode so that you can see the numbers very clearly. At the end of each section today, there will be time for question and answer. We will be using the chat pod, which is over on the left-hand side for those questions. And I'll remind you again at the end of each section. But if there is something that, as you hear it, that brings up a question for you, you can feel free to put that a question in the chat pod at any time, and I will go back to it when we do hit one of those question and answer periods. As I mentioned earlier, there is a handout pod at the bottom of your screen. There you can download today's presentation as well as a training announcement that will be discussed about usRAP that's going to be happening in July. Also, we will be having 2 follow-up surveys that we will send. I just mentioned one of them again. One of them will be sent to you at the immediate close of today's webinar, and that one is to get some feedback on our presenters and the topic and see what additional topics might be of interest to you. During that survey, you can also check whether or not you'd like a completion certificate or a CEU sent to you, both of which are free, but you do need to fill out that evaluation form in order to receive those. In about 3 months, we'll then send a follow-up survey to see if you've indeed used any of this information that you learned today, if you've passed it along to anyone at your job, or if you have put it into practice. So perhaps you've called and found out more information or started using the data software that is going to be explained to you today. Today's presenters are Bruce Hamilton from the Roadway Safety Foundation and Doug Harwood from MRIGlobal. Bruce is the Director of Safety and Research Programs at the Roadway Safety Foundation, a nonprofit organization in Washington, D.C. dedicated to advancing the hard side of highway safety: roadway design, roadside environment, and operating conditions. This is his second stint at the Roadway Safety Foundation. In between, he served as a communications manager at the AAA Foundation for Traffic Safety. Bruce oversees the Roadway Safety Foundation's support of the U.S. Road Assessment Program and other initiatives. He's also pursuing a Master of Public Health at the George Washington University's Milken Institute. Doug is a program director in Transportation Research Center at MRIGlobal in Kansas City, Missouri. Doug has over 40 years of experience in highway safety research and development. He has served as principal investigator for usRAP since 2004, first for the AAA Foundation for Traffic Safety and now for the Roadway Safety Foundation. He has also led or participated in the development of other key safety tools, including the AASHTO Highway Safety Manual and Safety Analyst. Doug has a BS in Civil Engineering from Clarkson University and an MS in Civil Engineering from Purdue University. And the Safety Center is very thankful that they were willing to speak today for all of you. And now I am going to turn it over to Bruce to start the webinar.
Well, thank you very much. This is Bruce Hamilton from the Roadway Safety Foundation, and we are very thankful to the Center for hosting us and for inviting us to be part of the monthly webinar program. So thank you so much, and thanks for getting us online and helping us through all of the technical pieces of this. Before I turn it over to Doug, who is the technical expert and who will be going through the demonstration and some of the details of this, I'd just like to provide a very brief overview of what usRAP is, just to set the stage for Doug, to provide some context, and to show the overall goal of the webinar. By the end of this hour and a half together, we hope that you will have an understanding of what usRAP is, what its core protocols are, and why we have chosen this as a venue to present it, why we think it's so especially relevant in the case of rural roadways. We have 4 learning objectives for you today. First, to identify usRAP's function and its unique value proposition for safety analysis. Second, to understand the application of the VITA software in generating star ratings and safer road investment plans. And Doug's going to be talking a lot about that. VITA is the software that feeds usRAP. So we'll be going into that and seeing a demonstration using the VITA software through the demonstration that Doug will provide, and then learning how to pursue a usRAP project by contacting us and taking the next steps for us to work together. I am going to go through the first piece of this, as I said, and then I'll turn it over to Doug, but talking about usRAP's function and its unique value in safety analysis. The United States Road Assessment Program has several main objectives, and I just want to mention these now to set the stage for what we're going to be looking at. Doug, as I said, will go into how we achieve these objectives, but this is really the overall vision for usRAP. It seeks to reduce fatal and serious injury crashes. That is its main focus. Of course, we certainly want to reduce all crashes, but the real purpose for usRAP is reducing the risk of the fatal and serious injury. We also want to ensure that highway safety improvement programs and those precious limited resources and dollars are based on a rational assessment of risk, making sure that those investments are targeted to where you can get the biggest bang for your buck. usRAP is fundamentally at heart a cooperative type of program. We want to be collaborative. We want to provide tools. We want to provide assistance. This is not about having one way, the only way, our way, or anything of that nature. We very much view usRAP as a value-added and one important piece of a larger portfolio for doing safety work. Part of what usRAP does is it can provide a benchmark of the safety for road segments. As I said, it can help allocate resources based on risks. These could be infrastructure resources, which is really what we're going to be focusing on, but potentially even broader resources such as enforcement, informing and providing guidance to motorists, and fostering, as I said, collaboration. This is really a collaborative effort. A brief history, usRAP was established in 2004 by the AAA Foundation for Traffic Safety, and they did some terrific work piloting usRAP at the state level and really establishing it as a validated program and approach in the U.S. context. It was modeled, though, on successful efforts in Europe, EuroRAP, and Australia, usRAP. And as you can see here, and this is not even a complete list, usRAP came along sort of third, and then in 2005, IRAP, the International Road Assessment Program, was started. It's a UK-based charity to now coordinate all of the RAP programs. Now there's also a China RAP, there's an India RAP, there's a Kiwi RAP in New Zealand, and then one of the things that IRAP does is it takes the lead in projects in countries that do not have their own standalone program. So work that's done in the United States is done by usRAP. Work that might be done, say, in Tanzania would be something that IRAP would sort of have under its umbrella. But as you can see, the RAP programs are now active in over 70 countries. This is overseen by a global technical committee that Doug serves on to assure the technical quality of the protocols and the research that goes into feeding the software. And the IRAP model, as I said, has now been used for well over 10 years. In the United States, the Roadway Safety Foundation is the primary sponsor for usRAP. The AAA Foundation had it from 2004 to 2014. So if you have any familiarity with usRAP in that time frame, you'll likely think of it as a AAA Foundation program. The Roadway Safety Foundation is a charitable group in Washington, D.C., dedicated to promoting road design enhancement, safe roadsides, and safe operating conditions. And when it came time for usRAP to have a transition, it just fits in so perfectly with our mission that it was a very natural thing for us to take over. We are fortunate and very thankful for a cooperative agreement that we have with the Federal Highway Administration that allows us to do our important work and that has supported our efforts in usRAP. And FHWA promotes usRAP as one of several tools that may be appropriate for doing data-driven safety analysis, particularly as part of the Everyday Counts 3 initiative. You've got my contact there, and my contact information will be coming up again, so no need to worry about that now. Very quickly, the usRAP model can be used anywhere, and it can be used on any road network, but there's a reason that we really were excited to present this here and in this forum, and that's because it really does have particular value added, we think, in rural areas. The IRAP vision is a world free of high-risk roads, and if that sounds very ambitious, it is, but we are no stranger to ambitious goals. Think TZD, Vision Zero, which is gaining popularity in American cities. And ambitious goals like this require ambitious plans, and I think you'll hear from Doug that what usRAP can contribute is ambitious and is going to be vital in the effort to achieve zero deaths, zero high-risk roads, and some of the other major goals that we have set for ourselves. One of the things that the Vision Zero network says sometimes is that not all E's are created equal, and that's not designed to pick a favorite or to alienate anybody, but it's really sort of fits in with what the IRAP and usRAP model is, that we need to have a safe foundation. We need to have a safe built environment. We are not going to be able to educate our way to zero simply because there are too many people and there is too much human error that we are all susceptible to. And until every vehicle is driving itself perfectly, which is a long way out, we really feel that the engineering piece is critical, that it needs to lay a safe foundation for all of our other E's and all of our other efforts to build on. So IRAP and usRAP are firmly of the belief that we can design out a lot of the risk in roads and that we can create a cultural shift that will support some of the work that we're doing, but also these broader efforts to get to zero deaths and to a world free of high-risk roads. In rural areas specifically, there's often a lack of data that feeds some of the more traditional safety tools. State DOTs may have solid crash data, but locals and counties often don't, and about 75% of the nation's road mileage is under local control. And what you're going to be learning from Doug is that usRAP can be used anywhere. It's based on video and predictive modeling, not on crash data. But it's especially value added where the crash data either is missing or is lacking or unreliable, which often happens in local areas, rural areas, where the hazard potential of a road may be very high. If you think a two-lane rural highway that's high speed, no median divide, maybe roadside hazards or culverts, things like that, certainly usRAP is going to be a tremendous resource for assessing that. And then sometimes we also see where VMT is so low that the risky nature of the road doesn't really show up reliably in crash patterns. And again, this is a predominant issue in rural areas where there may be a dangerous roadway, a dangerous roadside, but your crash data isn't really going to show that in an actionable way because the traffic is just too low. usRAP can provide a value-added and in some cases potentially the only data-driven tool to capture that and to think through some rational solutions. So with that, I'm going to close my section and turn it back over to the center for managing the Q&A, and then when we come back, Doug will be picking it up. But thank you so much. We're really, really thrilled to see so many people here.
And thank you, Bruce. And now we will take questions for Bruce if you do have any. Again, we are using the chat pod over on the left-hand side. And while we are waiting to see if anyone has any questions, we do have a first poll question for you. The chat pod will still show up over there on the left-hand for you. usRAP is the first road assessment program created. True or false? And while we are waiting, it looks like we have one question coming in. Bruce, another question that we already have for you is, what is usRAP's actual relationship to IRAP? Would state or local agencies that work on a usRAP project also need to coordinate with IRAP?
So thank you. So we are part of we call it the RAP family. It is formal in the sense that the Global Technical Committee feeds the software. The software is the same for everybody. The protocols, the research that goes into these models are validated internationally. They come from global research, a lot of which, of course, does happen in the United States. But we are not sort of technically part of IRAP. So if we have a county that's doing a road assessment program project anywhere in the U.S., they're certainly going to benefit through that software of the best that the global research has to offer. But no, they would be working with us or with Doug's team, or if they've been trained as their own provider, they can do it themselves. There's not sort of a larger formal hierarchy. We handle that work so that we know that the usRAP tools and products that we're pushing out are the best that they can be, but others will not have to worry about any kind of larger bureaucratic anything to deal with.
Perfect. And that did also allow for another question to come in. So your next question is, are there technical differences between usRAP and the international version?
So let's see, and Doug will go into this a little bit more. One of the things that we've been working on is making sure that the software is sort of directly translatable to the U.S. context. So technically, there are not technical differences, but we have had to work through, and I think some of that is still ongoing, making sure that units and some of the vernacular and things like that are appropriate in the United States. But no, it's technically it's part of the VITA software that Doug is going to go into. And Doug, when he takes over, or now, Doug, if you want to weigh in, we are working to make sure that it's appropriate in a U.S. context.
Okay. And it sounds like, Doug, did you have anything you'd like to add to that?
No, I think I'll just comment as I go along in my presentation.
Okay, perfect. Bruce, I have closed out the poll for you and broadcasted your results if you'd like to go over that.
Well, it looks like most people got that. That's correct. It's false. We were the third. There was usRAP, usRAP, and then usRAP was modeled on those two, and then IRAP came after to start coordinating our efforts. And Peter Kissinger, who's the former president and CEO of the AAA Foundation for Traffic Safety and serves on the IRAP board, he was instrumental in getting usRAP off the ground with Doug. So we all owe a huge thanks to Peter and the AAA Foundation, but we were not the first.
Thank you once again, Bruce. I know we're going to hear from you a little bit later, but we're going to be turning the presentation over now to Doug to discuss the next few learning outcomes. Doug?
Okay, thank you very much. Our next learning goal here is to understand the application of the VITA software in generating star ratings and safer roads investment plans, and we will then follow that up with a demonstration of the software. I lead the usRAP team that since 2004 has been working toward the development of the program and publicizing what we're doing and what's available to help highway agencies. As was said in the introduction, I am with MRIGlobal in Kansas City, Missouri. Also part of our team are Iowa State University in Ames, Iowa, and the University of Kentucky in Lexington, Kentucky. Part of what we do as a usRAP team is provide technical assistance and support to anyone who's interested in becoming part of usRAP or using the software. That is paid for through our agreement with the Roadway Safety Foundation, so we can help provide some free technical assistance to anyone who wants to take advantage of these capabilities. My contact information is there, and we will repeat that later on. So there are altogether 4 protocols that have been used in the usRAP program. Risk mapping, which is based on crash data, performance tracking, which is based on tracking risk mapping from year to year. We're not going to emphasize those in this presentation. We are going to emphasize star ratings and safer roads investment plans. That's what I will be talking about. But all of these protocols are based on evaluating and managing the risk of fatal and serious injury crashes. So what is a safer roads investment plan? Why would we care about developing one? Well, a safer roads investment plan is a plan that suggests specific safety improvements at specific locations on a selected roadway network. So this is a planning tool. usRAP has a planning tool that can help you decide what locations on your road network ought to be improved, have improved infrastructure, and what kinds of improvements ought to be made at those locations. The input data for the development of safer roads investment plans is a data set of approximately 50 roadway and traffic characteristics that are coded for each 100-meter segment of a roadway network. 100 meters is about 327 feet. That's the basic building block of what the RAP software works with. And we'll talk about, as we go forward, what these 50 roadway and traffic characteristics are, how one gets data on them and assembles them as input to the software. The processing software for those data is a web-based software tool known as VITA. There is no particular rationale for that name other than VITA is the Spanish word for life, and we're certainly looking for ways to save lives and prevent serious injuries. The output of developing safer roads investment plans is a safety improvement plan for your road network. It's a plan that can help you decide what kinds of improvements might be appropriate. So what does a Safer Roads Investment Plan include? Specifically, the plan would suggest specific countermeasures to be implemented, suggest specific implementation locations for those countermeasures, provide quantitative cost estimates of what those countermeasures would cost to implement. The plan would quantify the safety benefits of those countermeasures, both in terms of crashes reduced and in terms of dollar benefits. The plan would include both cost effectiveness measures and benefit cost ratios. And in fact, the plan is entirely based on benefit cost analysis. The user gets to select a minimum benefit cost ratio that that all countermeasures in the recommended plan would have to meet. And so the user has some control over the size of the program and the kinds of benefits that would come from the program. The size of the program can be made larger or smaller by selecting the minimum benefit cost ratio. The output for a plan is in the form of tables and maps that appear on the screen in the software, and also the data can be presented in Excel spreadsheets that can be downloaded from the software and that one can work with in studies toward implementing the plan. So how can a Safer Roads Investment Plan help your agency? Well, the plan focuses attention on the priority locations for safety improvement on the road system and the appropriate type of safety improvements for each location. Now, what comes out of the software and what's in the plan are just suggestions as a starting point for the consideration of what improvements to make. If the software recommends putting in a roundabout at a specific location and the detailed engineering studies that follow the plan development suggest maybe a signalized intersection might be more appropriate there, or vice versa, we wouldn't be the least bit surprised. The safety planning software in VITA is not a substitute for good engineering. It's just a way to focus the engineering very quickly on the right locations and the right types of improvements. But the final decisions are based on engineering studies, and the final decisions get made by each agency. The assembly of the input data can be coded from looking at visual tools, videos of roadways. For example, a lot of our data now gets coded by using Google Earth and being able to see aerial views and street views of the roadway, Google Earth and Google Street View. It takes approximately a 30-minute investment of time to assemble the input data for a mile of road. So that's the kind of input that's needed to use the software. The coding, we'll talk about the coding more in the future. It's often done by university students or technicians who can be trained to assemble the kind of input data that's needed. And indeed, in some cases, the data already exists in an agency's files, and we can use data that already exists rather than having to code it all again. All of the results are based on benefit cost analysis, and as I said before, only improvements that meet a certain minimum benefit cost ratio that you get to specify are suggested as part of the program. So The VITA software that we're going to talk about performs this network-level safety planning analysis to provide a safer roads investment plan. The software is web-based and it's easily accessed online. And the software is free for anyone to use. It can be used for free by highway agencies and by their consultants. We can certainly talk with anyone who's interested as a follow-up to this about how to get access to the software and how to use it. Now, it does take some training to use the software properly, and especially toward the coding of data as input to the software. And at the end of this webinar, we're going to be telling you about a free training opportunity that is coming up next month in July. So the software uploads and processes the input data for most roadway systems, like the size of a county or a district in a state. It can process the roadway system within a few minutes. A county road system, perhaps within 5 or 10 minutes. A district of a state highway agency, perhaps 15 or 20 minutes. But it goes from the input data file to all of the results that get displayed on screen and in downloadable files in just a few minutes. The software does not use detailed site-specific crash data. It is risk-based software that uses crash prediction models to look at risk. So it's not dependent on the accuracy or the completeness of your crash data set. However, some network-wide crash data is useful for calibrating the model to match your local conditions. So who can most benefit from Safer Roads investment plans? Probably it's of the greatest benefit to highway agencies without good crash data. If an agency has no crash data available or has crash data in manual files or has automated crash data files but no really good location data in a computerized form other than verbal descriptions, really this software can serve the function that might be served in crash data analysis in other agencies. But any agency can really benefit from this as a supplement to whatever might be done in the analysis of crash data. So it's useful certainly for highway agencies with good road inventory data, but any highway agency with video coverage of its road system can assemble an appropriate input database. And in the age of online tools like Google Street View or Bing Street Side, that's almost everyone. The coverage in the U.S. of even our local road systems is quite extensive in these online tools that are available. So the usRAP analysis process basically works as shown here. You start with coded roadway attribute data. That data are used in the software to develop road safety scores that are really proportional to the risk of crashes. And from those road safety scores, we can generate both star ratings and safer roads investment plans. I've talked a little bit about safer roads investment plans. Next, I'm going to get into what star ratings are and how they're useful, but the star ratings are just a step along the road to getting a safer roads investment plan. So let's talk a little bit about star ratings. What is a star rating? Star ratings are assigned to roadways, and they can be assigned to sections as short as 100 meters or about 300 feet of roadway, based on the presence or absence of road design and traffic control features that are related to safety. So the 50 safety-related design and traffic control features that we talked about are many of them are considered in the star ratings. And star ratings are typically rated on a 1 to 5 scale. A 1-star road is a road with limited safety-related design and traffic control features, kind of like your simplest, most basic 2-lane undivided road might be a 1-star road. Up to a 5-star road is a road with the full range of known safety-related design and traffic control features. A 5-star road is essentially like the best freeway that we know how to build with all of the safety-related design and traffic control features that can be incorporated. In implementing star ratings, there are separate star ratings by user type. There are separate ratings available in the software for vehicle occupants, for motorcyclists, for pedestrians, and for bicyclists, depending on how well the roadway is suited to accommodating them. Originally, it was thought perhaps there'd be one overall star rating for a road, but when we actually looked at this, the factors that are important to safety on the roadway for vehicle occupants and for pedestrians and bicyclists are quite different, and therefore it didn't make sense to try to have one overall star rating. Now, some of the key safety-related features. These are examples of some of the 50 key safety-related roadway characteristics that are used to generate both the star ratings and the Safer Roads investment plans. These are collected into a database based on 100-meter or about 300-foot intervals along the roadway. So the key input data include the number of lanes on the roadway, whether the roadway is one-way or two-way, the roadway width or the lane width or the shoulder width. And for purposes of this software, lane width and shoulder width are characterized in rather broad categories like narrow, medium, and wide. And we have specific definitions of what narrow, medium, and wide are. But it's not necessary to apply this software to have detailed data with lane widths and shoulder widths to a tenth of a foot or something like that. It is, even in those general categories, it's possible to produce a very good investment plan for the roadway. Horizontal alignment, especially some broad categories of curve radius, vertical alignment, and grades. Other factors include the quality of the delineation and marking and delineators and so forth along the road, the road surface condition, the presence or absence of sidewalks along the road. The roadside severity. Roadside severity is rated in terms of what are the most severe obstacles along the roadside and how far are those obstacles from the edge of the traveled way. The presence or absence of shoulder rumble strips, the access point or specifically driveway density, the type of median, if there's a median present, what type it is. For intersections along the roadway, where they're located, what type of intersection, how many legs does the intersection have, what kind of traffic control is present, are there turn lanes present, and so forth. Pedestrian facilities and bicycle facilities are considered. The area type is classified as rural or urban. Land use is classified, while it says here commercial or residential. We also now use some other categories, undeveloped, agricultural, industrial, educational, and so forth. There are 3 variables that we train coders to rate on the roadway: the qualities of curves, intersections, and pedestrian crossings. Basically, this deals with how well these features are visible from the approach, what kind of sight distance is available to these features, and how well they're signed and marked so that approaching drivers are aware of their presence and can respond to them properly. There are also some key operational and traffic control characteristics. Traffic volume, or the ADT of the road, is a basic characteristic without which you can't really do a safety study. We basically get traffic volume data from the highway agencies that participate. We also make some estimates of, well, motorcycle percentage is in there. Basically, that's in there for use in some other countries. There are some Asian countries these days where 50 to 80% of the vehicle fleet are motorcycles. So without considering that, you really can't look at safety issues. Motorcycles are actually a growing problem in the U.S., but basically their percentage is relatively low and it can be estimated. We have some rules of thumb for estimating pedestrian and bicycle flow on facilities from the other data that are gathered, but we also use local knowledge in estimating them in categories like low, medium, and high. Same way, intersecting road volumes. We know that highway agencies often don't have data on the volumes on minor roads and intersections, but if they're available, we use them, and we also have some guidelines for estimating those. Also, some data on speed limits can be gotten from signs on the roadway or from whatever the laws are concerning the default speed limit where no sign is present. And if speed data like 85th percentiles and mean speeds are available, that is also used in the software. The data are assembled into a coded roadway file like the one that appears here. And basically, the first 10 or so columns here are location information. The columns represent the various road attributes. Each row in the spreadsheet like this represents a 100-meter section of road. And the first 10 columns or so are location information, including the distance along the road, and latitude and longitude. The rest of the columns represent all the coded roadway attributes. But the input data for the software is a very simple Excel file like this, very easily assembled and uploaded. As I've said, we basically use video or photo images for coding data. This is an example of the kind of coding tool. This is something we've used in the past. We now have some coding tools that work with Google, Google Street View, Google Earth, Google Maps. But basically the principle is you have some photographic images of the roadway. You set the photographic image at the start of a route. You have some drop-down box with drop-down menus on it. This is usually presented across dual screens. On the first beginning of the roadway, the coder uses the drop-down menus to code all the roadway attributes. Then the coder clicks a button, and the visual image moves forward 100 meters or 300 feet. Most of the data can be held. Most things don't change over a short interval like that, but then the user goes in and resets the drop-down boxes for anything that's changed in that 100 meters, clicks the mouse again, and the image moves forward 100 meters. Update this, and you can move down the file this way, move down the road this way, coding data, and that data all goes into an Excel spreadsheet that can then go through a quality review and then be uploaded into the VITA software. The road safety scores, I'm not going to go into a lot of detail about this, how this scoring is done. That could be a whole course just unto itself. But suffice it to say that there are specific types of crashes considered for each road user type. The risk factors are identified for those specific road attributes, and then the attributes that are scored are on these slides. I know that you'll be able to download this presentation and can can study these, but it identifies the kinds of road attributes that are considered in scoring for vehicle occupants, for road attributes, for vehicle occupants, for pedestrians, and for bicyclists. This graph here shows examples from a TRB paper we've prepared, showing that as the star rating of a roadway increases, the crash rate really does go down. And this TRB paper is a strong demonstration that these ratings really do relate to safety. Then indeed there are summaries like this that appear in the software. We'll show you that in the demonstration. I want to move on to Safer Roads investment plans. So the Safer Roads investment plans are a site-specific plan for cost-effective safety improvements. They include safety improvements for the entire road network. They're developed from the same database as the star ratings. And as I said before, they're based on road attributes without the need for site-specific crash data. The Safer Road Investment Plans considers over 70 countermeasures that could be implemented on the roadway, and each countermeasure is reviewed for each 100-meter segment of the roadway. A countermeasure is triggered if it makes engineering sense for a given segment of the road. And once the countermeasure is triggered, then an economic analysis is performed to see if it should be part of the plan. The countermeasures are incorporated in the plan for a given 100-meter road segment if the countermeasure is not already installed, if the benefit cost ratio exceeds the minimum benefit cost ratio specified by the user, if the countermeasure is compatible with other cost-effective countermeasures for that same location, if the countermeasure is not overridden by a mutually exclusive countermeasure for the same location that is more cost-effective. For example, the software wouldn't recommend both a roundabout and a signal at the same location because they're mutually exclusive. You use either one or the other. The countermeasure is consistent with countermeasures recommended for adjacent road segments. All analyses in the plan and all the benefits are based on consideration of fatalities and serious injuries. And the ratio of serious injuries to fatalities is based on actual crash data where that is available. For calibration, the user provides data or the best available estimate for network-wide average fatalities per year, and then program logic decides how that risk would be spread over the various road segments. And the results can be reviewed or verified in a download file. So with that, we've completed the presentation. We're going to go on in a moment to the demonstration, but I think we're going to stop here and turn it back for a moment to our hosts.
Thank you very much, Doug. And now we will take any questions that you have if you'd like to type them in on the chat pod. And as we are waiting for some of those questions to come in, we are going to do another poll question. Which of the following is true about star ratings? Is it that they are assigned based on presence or absence of road design and traffic control features related to safety? Star ratings consider over 50 safety-related design and traffic control features. Star ratings are assigned on a 1 to 5 scale. A star rating is provided for each user type. It requires a 30-minute investment in input data coding per mile of road. All of the above, or I don't know, I don't remember. And it does look like we have a few questions that came in. Your first one is, how does the presence of safety hardware such as beam guard affect usRAP ratings? And could the software distinguish between standard and substandard guardrail?
Well, the ratings include a roadside severity rating for both the left and the right side of the road, and the presence of guardrail is one of the roadside features that can be entered into the database. I would say the software can't distinguish between standard and substandard guardrail, but one could train the coders to distinguish between them.
Thank you. Another question that came in for you is, can the land use data be downloaded from census data?
There could be something developed to estimate that. It's really not difficult for the coders as they go along to rate the land use on what they see, but we indeed have had at least one agency that, for example, has identified schools and educational land uses and some other things from planning data of various types.
Another question that has come in for you is, do safer roads investment plans take the place of traditional engineering studies conducted in project development?
Absolutely not. They are the precursor to engineering studies. What the Safer Roads Investment Plan can do is direct the limited resources that are available for engineering studies to the right locations and the right general types of countermeasures. But the final decision always needs to be made based on an engineering study.
And it looks like we do have another question coming in, so I'm going to take the time while they're finishing typing that to broadcast the results and end the poll if you'd like to discuss that, Doug. And we'll wait and see if that question comes in. You should see the answers now on your screen.
Okay. Well, all of the above was rated as 90%, and all those attributes that were described are indeed attributes of star ratings. I think in the interest of time, we probably better move on at this point. If there's time at the end, I'll be glad to come back and respond to any additional questions that we've gotten.
Okay. And so our next section is you going through the live demonstration of the software. And if everyone can bear with us for a few minutes, this will take just a few seconds to get his screen to show. And again, I will remind you that once it is showing, if you do click the 4 arrows, that will make your screen full screen, and it will make it a little bit easier for you to see this. I do want to remind you as well that because he is sharing his screen, there could be some lag time with everyone's different Wi-Fis that you're on. If there is an issue with that, again, we are recording this so that it will be available later if you do need to come back and watch it again if your Wi-Fi is not able to handle the live streaming.
Okay, can you see my screen now where it says Welcome to VITA?
Dana, are you guys able to see it at Montana State?
Not yet. It's still cycling.
Okay. Let me know when you see it.
While we are waiting to see if that comes up, why don't we take one of these other questions that came in?
Okay.
And Dana can see if she can figure out what's going on. The next question was, would you say that the inputs are both qualitative and quantitative for
Well, let's put it this way, that some of the inputs are quantitative, others of them, I don't know, some of them might be called qualitative. I'd also say they put things into categories, so you might call them categorical. One of the things we do in our training is go in complete detail into all of the input data and how to code them. Is the screen showing?
Yes, I can see the screen here at MSU. Jamie, can you see?
I can see it now too, so I think you're clear to move forward.
Okay. Well, on the screen here, we have the login screen. The first thing I'd like to emphasize is that the data in here are password protected, and that if your data goes in here, you can control who has access to your data. So it's possible for you to make your data visible to others, but normally the only people who can see your data is your agency's representatives and those of us who manage the program. So we get a screen like this. I don't have an opportunity with the time we have available to show you every bell or whistle in this program, but lots of data of different kinds have been uploaded here. The Utah Department of Transportation has very kindly authorized us to show some of their data in this demonstration, so that's what I'm going to do. I'm going to click on the tab here that says Results. And the first thing that one would go in here and do is pick Utah and Utah state routes. And I'm going to take one region in Utah just as an example. Click Apply Filters and Options. And now you should see appearing on your screen, and it's taking a little while even to appear on my screen, a star rating map for the roads in one section in Utah. It is loading slowly, and I don't know why that should be even on my screen, but apparently being hooked up to this software is slowing things down. Well, this is disappointing because the software normally loads very quickly, and in our practice run the other day, it worked fine, but apparently it's not going to work quickly with so many people online like this. So we have a backup plan, and so I think I'm going to stop sharing my screen now. And if our colleagues at Montana State could load the backup slides, I would sure appreciate it.
Yes, and while Dana does that, there is another question that came in that perhaps you could answer. It's,
Okay.
Would you say that this is more appropriate usage for rural or urban systems?
It has been used most widely for rural systems, but it can also be applied to urban streets, and it has been applied to urban streets. Okay. So I'm going to click Stop Sharing here.
Dana, could you please fix the screen again?
If you could fix the screen and bring up the backup slides, I would appreciate it.
Okay, you're all set to go ahead.
Okay, it still shows loading on my screen.
Doug, can you not see the slides?
Now I can. They just appeared. Okay. So we went through the login process. Let me take some things in order, and I'll just show you what you could see if we could do a live demo. First of all, there is a capability in the software to look at the distributions of every one of those 50 input characteristics. So, for example, I'm showing here, this is for, I believe, either a whole region in Utah or it might be for the whole state highway system, the distribution of intersection types. And you can see here, for example, as you might expect, 83% of the 100-meter sections in Utah have no intersection, but here we can see the various types of intersections and how many of those types of intersections there are. So one very valuable thing of this database, once it's assembled, is it can function like an inventory system for your roadway network. If you don't have an inventory system, it can tell you all about the mid-block characteristics and intersection characteristics and so forth on your system. Now, this is a star rating map, happens to be for one region in Utah. The roads are color-coded on the map. The one-star roads are coded in black, two-star roads in red, three-star roads in orange, four-star roads in yellow, five-star roads in green. You can see that most of this these are basically all of the state highways in this region with the exception of interstate freeways, which were not included in the study. Most of the roads here are in the 2- and 3-star category, which is pretty typical of rural 2-lane highways, which most of these roads are. These are the star ratings for vehicle occupants. The software will also show you star ratings for pedestrian and for bicyclists. This happens to be the bicyclist star ratings, and here are the pedestrian star ratings. Not every roadway has a pedestrian or a bicyclist star rating. Only the roadways that are rated as having at least some pedestrian flow or some bicycle flow have a star rating that is displayed. The software will display tables like this that show the distribution of star ratings over the roadway system. You can see that this roadway system being looked at here is for vehicle occupants is 17% one-star roads, 53% two-star roads, 26% three-star roads, 2% four-star, and 3% five-star. And just recall I said that there really are very few freeways included in this. But a table like this can be displayed online. Now, you can also drill down with the star ratings as you can with all the data. This is drilling down. Now, this map shows just one particular route on the Utah system, and it shows how risk varies along this route. And indeed, you can drill down to just a given section of road. We had a question about urban roads before. This happens to be an urban section, and it shows you what the star rating on that road is. A very interesting feature of this, in that it's doing a risk analysis of the road, is this slide shows you how the star rating and thus how the risk of crashes varies along the road. The peaks that you see sticking up here into the 1-star area. These are intersections, and especially this would be a major intersection along that road. And indeed, on just about any rural road or urban road, the highest risk sections are the intersections. And it shows the areas between intersections are basically, and even many of the intersections are in the 3-star category. This is not a view of our roadway system that most people have seen before, but it's a way to look at how risk really varies from site to site along a road, and this can help you think about where some safety improvements might be directed. This table just illustrates the countermeasure costs that are put in here for use in benefit cost analysis. This is just a little snapshot of a few countermeasures and the data that's put in on costs. Individual agencies can put their own cost data in for rural roads and for urban roads. Low cost, medium cost, and high cost values of unit countermeasure costs can be put in. Here, for example, are bicycle lanes and on-road and off-road, and unit cost information on those. This can be tailored to an individual agency's data so that the analyses are appropriate for that agency. I just wanted to illustrate this is one of several ways in which the analysis can be tailored to an individual agency. This is the kind of display that you see when you pull up a Safer Roads investment plan. This is the Safer Roads investment plan for a region in Utah. It shows at the top here that if this entire plan were implemented, and it probably wouldn't be because there are going to be engineering studies done that could change what countermeasures are in the plan. But if this plan were implemented over a 20-year period, it would reduce 672 fatal and serious injury crashes. That would have a safety benefit of $609 million at a cost of $46 million, with an overall benefit cost ratio of $13 in benefit for each dollar spent. Now, this program was developed with a minimum benefit cost ratio of 6, so every countermeasure for every 100-meter interval that's part of this program, it has at least a benefit cost ratio of 6 to 1, but in many cases it's more than that, so the overall program has a benefit cost ratio of 13 to 1. Each line in the plan itself identifies a specific countermeasure and shows overall how many, in this case, kilometers of road would be improved as part of this plan, and it shows the crash reduction, the safety benefit, the estimated cost, and the benefit cost ratio for each countermeasure, each type of countermeasure over the system. Now, if one were to click on any line in that program, it would open up a map on the screen like this, and the blue dots on the map show the locations where that particular countermeasure might be implemented. What I've opened up here is a map for signalizing 4-leg intersections that are currently unsignalized. Now, keep in mind that the software doesn't have detailed signal warrant data. It just has ADTs and for the major and minor roads. But this gives a good idea where some signal warrant studies might be done. And indeed, I've never shown the results like this to a highway agency where they didn't say, oh, well, that location there, that signal's under design right now, or something like that. it gives a lot of face validity to this information. But it suggests places that could be studied. Now, one of the things that's important is it doesn't just generate these overall maps as the location for improvements, but there are download files like this, what we call the countermeasure download files, that come out that show exactly what improvements are recommended, where they're recommended, identifies specific locations by distance along the road and also by latitude and longitude. So there's no doubt about what countermeasures are being recommended, where they're being recommended, and for each 100-meter interval level, it's showing the potential benefits, the potential costs, the potential crash reductions from those countermeasures. The countermeasure download file here not only includes every countermeasure in the recommended plan, it also includes every countermeasure that was even considered for inclusion in the plan. And if it's not included in the plan, the file tells why it wasn't considered, why it wasn't put in the plan. Either its benefit-cost ratio was too low, or it was overridden by a more cost-effective countermeasure, or whatever. So the download file is the complete information on the Safer Roads investment plan, and even things that aren't in the plan and why they're not in the plan, so that could be a potential use. I think we must be at the end of the file, because it won't when I click the slide, it doesn't go any further. These are our backup slides. Anyway, everything that's in the software, every display you've seen, can be displayed at the overall network level. It can be displayed for an individual route, and it can be displayed for an individual section. And when you get to this level of these download files, you have that information available at the 100-meter level. So I think that will conclude my presentation here. And so I'll tell our host that we're ready to move on to the next section.
Perfect. And we are going to open it up for questions right now. And again, while we are waiting for questions to come in the chat pod, we do have another poll question for everybody. Which of the following is not true about the VITA software? The user input star ratings, the output is a Safer Roads investment plan, the software is free to highway agencies and their consultants, it is web-based and easily accessed online, the software is only for use in urban environments, results are provided in Microsoft Excel files, and the user does not need detailed site-specific crash data. So again, which one is not true? So we do have a few questions that are coming in for you. The first is, why is the length in meters and not in miles? Okay.
Well, the length of an analysis segment is 100 meters. That is the standard that the software uses around the world. That is something that in the short term would be difficult for us to change. The lengths of improvements in the table I showed you are in kilometers. We are hoping before long to have an improved version of the software for U.S. application where those get displayed in miles. But we've done a lot of customizing of the software for U.S. For the U.S., we use now U.S. highway engineering terminology rather than overseas terminology. But for now, the outputs are in kilometers, which are easily converted into miles. But as we go along, we will have a more and more customized version for the U.S.
Okay, great. One more question that came in for you as well is, can the software use detailed crash data if you do have it?
The software does not use crash data except for calibration because it is a risk-based tool. However, the crash data are certainly a potentially important part of the engineering studies that are a follow-up to the countermeasure. If the countermeasure recommended in putting in a turn lane at an intersection or signalizing an intersection or putting in a roundabout, there will, after the implementation of the results will be through engineering studies, and the site-specific crash data would be very useful to those engineering studies.
Questions for now. So I have ended the poll question for you and broadcasted those results if you would like to address that.
Okay, well, the majority of folks, I think, identified that that the user inputs the star rating is certainly not true. The rest of the things in the question, in fact, were true.
Doug, this is Bruce, though. It looks like maybe we had a typo here because the third from the bottom is the software is only for use in urban environments. That is also not true. So I think, sorry about that, folks.
Okay, that is definitely not true. It's for application in both rural and urban environments. It's been used most in rural environments, but it is also applicable to urban environments.
Yeah, but apologies for that. It looks like we split the results there because we had two things to trick people, I guess.
Okay. Well, apologize for that.
And at this point, we are going to hand the presentation over to Bruce to do a wrap-up. Bruce?
Thanks again, folks, and sorry for some of the technical things, but thanks, Doug and Jamie, for getting the backup slides in there. I'm just going to conclude just quickly for everybody to tell you what the next steps can be if you're interested in either learning more or pursuing a project with us. Very quickly, our summary for you, usRAP is acknowledged by Federal Highway as one of a series of tools that might be applicable for data-driven safety analysis. It is applicable to any road or network, but we believe that it has a special value in rural areas and for agencies without robust crash data. And it is supported by a global body of research and technical expertise, and as Doug just said, is increasingly being tailored and customized to the U.S. application. We would love to work with anybody who is interested in pursuing a usRAP project. As Doug said, our agreement with MRIGlobal provides for them to give technical assistance to folks free of charge. At the end, we'll have our contact info again. The first step would be to reach out to us, either me or Doug. We are holding a training opportunity in July in Utah. We would love to see folks come to Salt Lake City and get trained. And when you participate in our training programs, it's considered preliminary accreditation. And then if you complete a project and submit the data back to Doug and his team for validation, then you can become an accredited provider. The software, the VITA software, is available at vita.irap.org. And anybody can sign up for an account. Of course, depending on what you're actually doing and the training that you've received will depend on the level of permissions that you get, whether you can input your own data, access other data, or simply play around in there. But the software is there, and anybody can sign up at least for the basic user account. The training that I mentioned will be the 27th to the 28th in Salt Lake City. Utah was really our first and huge, wonderful state-level partner. So we asked if we could do it in Utah so that in addition to the technical piece, we can also hear from the folks at Utah DOT about how they've applied this in the real world and the benefits that they're seeing from it. Registration is free and open to all. Attendees, as I said, can receive preliminary accreditation and then be equipped with what they need to go out and actually do a project of their own. We've, in the transition period between when the AAA Foundation had usRAP and now us, we haven't had a training program because we've been getting the administrative pieces together. But the AAA Foundation did a training a couple years ago, and I believe everybody who attended that went out and did a project of their own. The previous software was called usRAP Tools, and that was the software that the training that the AAA Foundation did focused on. So even if you or your colleagues attended that training, there would still be a lot of value in coming back because, as Doug has been talking about here, VITA is the new software, and there has not been a U.S.-based training on VITA to date. Moving forward, we would like to do more distance learning training because it certainly can be logistically challenging and expensive to do in-person programs. So we are looking to, in addition to doing webinars and things of overviews of usRAP, actually developing some distance learning courses to achieve what we will be delivering in the training. I will close it there for final questions, and then at the very end, the last slides have our contact information for taking the next steps.
Thank you. And again, we are going to take one last set of questions if anyone wants to put those into the chat pod, and we do have one more poll question for you guys. Do you feel that the usRAP program and the VITA software would be useful for your organization? Yes, no, not applicable, or I don't know. So as we wait to see if any final questions come in, we do have a few for you listed here. One of them is, if I'm not ready to sign up for a formal training yet, but I'm interested in having further discussions, are you available to answer questions and discuss the program in more detail?
Absolutely, and as I mentioned, part of our agreement with MRIGlobal is to provide exactly that kind of assistance, to talk through some of the benefits, to come up with sort of some ideas of what the logistics will entail. So yes, absolutely, and as I said, our contact information will be on those closing slides.
We did have a question come in through the chat pod, and that is, has anyone attempted to incorporate RAP star ratings into vehicle navigation systems, for example, to help drivers choose the safest route?
You know, that's a great question. One of the AAA Foundation's visions for the RAP protocol in the U.S. would be to develop some kind of a safest route navigation so that you could, you know, when you're going through, you can avoid tolls, you can choose the shortest distance, the shortest time, avoid traffic, or select the route with the best safety profile. To date, that has not occurred, and I think we have really been focusing on broadening the implementation of usRAP by governments and by DOTs. But that was certainly part of sort of the original long-term vision for one of the things that this could be used for. When I started, one of my early slides mentioned information for motorists and for the public. And you know, because some of these maps are user-friendly, and obviously there's a lot of engineering and technical back-end things going on here, but there is the option and the opportunity for some more public-facing, user-friendly kind of things. So the short answer, John, is no, but we have had that in the back of our minds, and it's something we'd love to explore moving forward.
Thank you. And one final question before we finish up is, would there be any reason why usRAP or VITA software would not be a good tool to evaluate HOV or HOT lanes?
I am going to let Doug take that because I believe that some of that has actually been done before. Doug, could you take a crack at that?
It certainly could be used to evaluate HOV and HOT lanes, as well as general freeway facilities or any other type of facilities. We have done some risk mapping, actually, looking at some HOV and HOT facilities. We have not yet applied the Safer Roads investment plan tool to that. And freeways may not be the strongest candidate for doing that, because freeways are already designed to some of our best design criteria, but it certainly could be done.
Thanks, Doug.
Thank you both. And I have closed out and broadcast the results of the poll for you.
Well, that's certainly what we like to see. So thank you all, and John, thank you for your comment in the chat pod.
Yes, and certainly I'd like to say we're about to put up our contact information again, and for those of you who feel like this would be useful, please feel free to get in touch with Bruce or with myself by email, and we'll be glad to talk to you further about this.
Okay, Bruce, I put up your last slide.
Thanks very much. So just to close out, these were the learning outcomes we hope we've covered: identifying usRAP's function and unique value proposition, understanding the VITA software and what its protocols and what its outputs are, seeing Doug's not quite live demonstration, but thanks again, Doug, and then the contact information, which is coming now, for taking the next steps. Well, not coming now. I guess I'll turn it back over to Jamie to close out.
Thank you. And we do have just a couple final slides for the Safety Center itself. Again, we do want to thank both Bruce and Doug for doing the presentation for us today. So thank you both for taking the time to do that. We do have, like we mentioned earlier, monthly webinars, and our next one will be happening the week of the holiday. It will be on Wednesday, July 6th. The time will be different this time. It will be at 9 a.m. Mountain Time. And this one will be also a little bit different of a format. We will have a roundtable on the public health side of rural transportation safety. We do have 4 distinct organizations who will be represented. We have Joe Merrick from Clackamas County, Oregon, who is a county engineer, Sally Clark, who is a county commissioner in El Paso County and also the NACO president, Howard Hedegaard, who is an injury prevention center specialist at the Children's Hospital of Dartmouth in New Hampshire, and Robert Morones, who is an injury prevention program at the Indian Health Services. And for this particular roundtable, we will be asking them questions about the public health side of rural transportation safety. As you do register, you are also encouraged to send in any questions that you would like us to ask so that we do have those beforehand. You can also, as I mentioned before, view all of our archived webinars on our website. This one will be posted within a few days. We do have some training videos as well on our website, including who is the National Center for Rural Road Safety, and also an introduction to road safety culture, which is about 12 minutes long. We are working on our National Working Summit on Transportation in Rural America, which is this coming September 7th through the 9th. The registration is open for this, and the draft agenda is now posted on our website, so you can get more information about the summit. And then again, thank you for attending our training this week. And here is the information one more time for Bruce and Doug so that you can get in touch with them if you have any further questions. Again, I will remind you that you can download this presentation out of the handout pod below, and also the training announcement for their training in July. And again,